Hello there. So today we are going to cover increasing triplet sequence. We are given an input of integer array nums and we have to return if this array consists of a triplet subsequence. If it contains triplet subsequence, then it's true, otherwise it returns false. So let's understand the problem statement with an example. So here's our first example given. If you manually see, the array will be indexed like 0, 1, 2, 3, 4, and the values given are 1, 2, 3, 4, 5. So now I, J, K will be our indexes. If you see 1, 2, 3, 4, 5 are in increasing order, and this indexes is also in increasing order. That is 0 is greater than 1, 1 is greater than 2, and 2 is greater than C. They are asking us the triplet subsequence. So it is to find whether we have three numbers in sequence and that indexes is also in increasing order. Yes, in this case we have three numbers in sequence and the index is also in increasing order, so it is a triplet subsequence, so we are returning true. Consider an example 2. Here if you see, if you can form any subsequence of three elements in increasing order, let us check. When you check 9, the next number is 8, which is less than 9, so 9 can't be included in any subsequence. So let's consider the next element 11. If you see 8 and 11 is in increasing order, so let's consider the subsequence of length 1. So now moving on to 6. When compared to 8 and 11, both the elements are higher than 6, so 6 cannot be included, or 8 and 11 cannot be included in a subsequence. So now moving on to 5, when you see the numbers before 5, every element is greater than 5, so you can't include 5 also in any subsequence. So we couldn't form any subsequence here of size 3. In this case we are going to return false. So if you think about this for a moment, you can relate to something we have already solved in our channel, that is longest increasing subsequence in an array. So we are going to use the same technique in this problem. The longest increasing subsequence will find the length of the longest subsequence in an array. So here we are going to use to find a longest subsequence which is greater than or equal to 3, because it is asking a triplet sequence. If there exists a sequence of size 3 or more than 3, then it satisfies the condition given in the problem. So in that case we are going to determine if the list formed is greater than or equal to 3, then it is true, otherwise it is false. So now let's get into the algorithm and go for a dry run with the example. So if you want to understand longest increasing subsequence problem, I have given the link in my description. You can check that. Here we are going to use the same concept to find a longest increasing subsequence of length 3 or more than 3. If that exists, then it is true. Otherwise, it is false. So let's get into our algorithm. Here we are having our input array nums. The concept we are going to use here is dynamic programming. So to store the values at each stage, I'm going to have an integer array dp, where this array dp stores the values of subsequence, length of subsequence till that point. So first, we are going to have two pointers I and j, where I is our scanning element. It moves every time it is done with the value, and j is representing the range from 0 to I. So we are going to have two pointers, as I said. I moves every time and j scans from 0 to I every time. So now we are going to have our I at starting at index 1 and j starting at index 0. First, let's see whether the value at position I is greater than value at position j, which means there is an increasing sequence. Yes, there exists an increasing sequence. First, our array will be filled with all zeros. So now we found one subsequence of length 1, that is 1, 2 forms a 1 and 2 forms a subsequence of length 1. So we are going to update here at the dp that till 2 we can form a subsequence of length 1. So now we have updated our value to 1. Now moving our j pointer to the second element, the loop ends, and we have to advance our pointer I to the next element and start j at 0. We have our pointer I at 3 and j starts from index 0. Now we are going to check whether 3 is greater than 1. Yes, 3 is greater than 1. So we can form a subsequence from 1 and 3. So now the length at 1 was 0, and from 3 it is 0 again, but from 1 to 3 we can form a subsequence. So I'm updating the length till 3 as 1 first. Now we have updated the length to 1. So now it is the j moves to pointer 2, and now it checks 3 is greater than 2 or not. Yes, it is greater than 2. So we are going to update our value to 2 because the length already there in position 2 was 1. Now we can append this to that sequence. In that case, we can update the value at 3. Now we can form a subsequence of length 2 till 3. So now again the j pointers move to this position. The loop ends. Now we have to advance our pointer I to 7. Now we have our pointer I at 7 and j at 0. We are going to compare whether 7 is greater than 1. Yes, it is. So from 0, from that is value of 1, we can add 1 to 7. So now we are updating our value to 7 as 1. Now we have 1 here. That is, we have some subsequence till 1. We can append 7 to that subsequence. So now moving our j to 2, we are checking whether j is less than 7. Yes. So we are going to add 7 to that subsequence. So the length of the subsequence we can form till 2 was 1. Now we are going to update our 7 to 2 because 1 we are going to add 7 to that. So the length will become 2. So now the length of 7 become 2. So again, now j moves to point 3 and checks whether 3 is greater than 7. No, 3 is less than 7. So again we can append this 7 to the subsequence till 3. In that case, the subsequence we can form till 3 was length 2. So if you add 7 to that length, we can add one more to this length. So 2 plus 1 will become 3. Now let's update the value of 7 to 3. So now finally the j moves to the place 7. The loop terminates. Now it's time to advance our pointer I. Now we have our pointer I at 5 and j starts again from 0. Now let's compare all the values whether 1 is less than 5. Yes. So we can form the subsequence from 1, that is 0 plus 1 is 1. So now checking again 5 is greater than 2 or not. Yes, it is 2. Again we can form a subsequence from there. So 1 plus 1 was going to be 2 here. So now again checking 3 and 5 we can form. So 2 plus 1 is going to be 3. And finally j moves to 7 and the pointer will be at I. So checking 5 is greater than 7 or not. 5 is less than 7. So in this case we can't append the value 5 to the subsequence till 7. In that case the value of the length of the subsequence we can form till 5 will be 3 again. Now finally our I reached the value 2 and j again starts from the value 0. We are going to compare the values. So starting from 1, if you check whether we can form a subsequence, yes, from 1 we can add 2 to that subsequence. So let's update the value to 1 here, and then 2 checks whether it is greater. No, again the j moves till 5. No values are greater than 2. So in this case we cannot append this 2 to any of the subsequence in the previous element. So the length of the subsequence till 2 we can form sticks to 1. Here our DP array is updated completely. Now we have a element max to keep track of the maximum value from array DP. So the maximum value is 3 in the array. So this, which means we can form a subsequence of length 3. So it is checking whether our max is greater than 3, greater than or equal to 3. In this case we can form a subsequence increasing triplet subsequence. So we are returning true as a value. So it is very pretty simple algorithm, just follow the same logic as that of longest increasing subsequence. So let's code now. As I said, I'm gonna have an integer array dp to store all the values of my uh, length of my subsequence. It is of length nums.length, and I'm going to declare a variable max to keep track of the maximum length of the subsequence. So I'm going to declare my two pointers I and j, where my I is going to start from index 1 and iterate till length of the array, and my j is going to start from 0 and iterate till I every time. So now we are checking if my nums of I is less than nums of j, sorry, greater than nums of j, then there is an increasing sequence. In that case, update our array dp. So dp of I would be max of dp of I or dp of j plus 1. And max is going to keep track of our maximum element from the dp. Finally, return if max is greater than or equal to 2, because here the size stores from 0, 1, 2, 3. So 2 means, which means the size of the increasing subsequence is 3. So let's run. Yes. So you can find this code in my description. Thanks for watching. Thank you.